Hey everybody, this is Mr. Ainsworth, and we're going to get into a little mind map on limosons here and the four different types. Okay, so let's get started here. We have a lot to do in a short period of time. So what you guys need to remember is that this is a technique of how to take a concept like polar functions, in particular polar functions on limosons, and develop a mind map covering all the different variations of the limoson or most of variations, okay? So some involving cosine and some involving sine, where A and B change sign and are different ratios. All right, so you got to choose these carefully. Obviously, I designed this, so I chose these carefully. And each limousin here in all four examples is different. And I'm going to go through the basics. And the goal of this exercise is to analyze and determine all the characteristics of the limousin without TID4 and without Desmos, without technology. And of course, we already went through the main lesson, and this is just a summary of the lesson that we went through, designed to get you guys to study more efficiently and effectively so you remember all this. All right, so let's get right into it. Let's take a look at our first limousin in the upper left. All right, and we got r is equal to 3 plus 4 cosine theta. So let's just compare it to the general form. R is equal to a plus b cosine of theta. And like I said, the limosons are different, whether it's sine or cosine, so we want to explore all the differences. Okay, so here we go. So in this case here, you want to start off with the ratio of A to B when you take a look at limosons of this form. And the ratio of A to B is 3/4, and obviously that is less than 1, which means we have a limoson with an inner loop. Okay, now I'm not going to go into all the specifics why, because we did that in the lesson. However, I will say this. It's important that you guys know how to substitute certain values in to get the minimum and maximum radius. So for example, this is cosine, and cosine assumes its maximum at 0 and 2 pi. So if I were you, I would take 0 and substitute in for theta and determine r. So in this case, r is equal to 3 plus 4 cosine of 0, and then you evaluate. And you've seen me do this in all my videos. I substitute key angles in, and they're usually 0, pi halves pi, and 3 halves pi. And then I figure out what the function equals, okay, to figure out the maximum radius. So cosine of 0 is 1. 1 times 4 is 4. And obviously 4 plus 3 is, well, that's 7. And so 7 comma 0 is on the graph, okay? Now, a quick and easy thing, when it comes to limosons, you take the absolute value of A and B values. I said absolute value of A and B, and you add and subtract them. So in this case, 3 plus 4 is 7. Look at that. And then you take B minus A, which is 4 minus 3 to get 1, and there's your length of your inner loop. You just got to figure out, how to get that inner loop. One way to do that is to substitute pi in, because cosine of pi will give you the minimum value of cosine theta. So let's do that just for funsies. Okay, so if you substitute in 0 for pi, you get r is equal to 3 plus 4 times the cosine of pi. And as you guys know, cosine of pi is negative 1 times 4 is negative 4, and 3 plus negative 4 is negative 1. So here you get negative 1 comma pi. Okay, so negative 1 comma pi is also in the graph. Okay, and notice that the absolute value of negative 1 is 1. That's the length of your inner loop. So go back up here when I added and subtracted. I take A plus B, and then I take B minus A, and that will give me your length of the inner loop. So inner loop length. I'm just writing down my thoughts. Okay, and then we can start graphing here. And then also, before we even get started, cosine, well, guess what? It's for cosine theta, it's symmetric about the polar axis. So that's another thing I know. So I'm just going to write it down up here. So for cosine, because I'm dealing with cosine here, is symmetric, okay, about the polar axis. And then that should make sense based upon what I've said so far in other videos, because that, all these functions have something in common, and that's one of them right there. Okay, so if you see cosine, we're talking about symmetry about the polar axis. Okay, having said that, here we go. I'm going to plot some points. So I need to plot 7 comma 0. So I got 2, 4, 6, and 7. There's 7. That's 7 comma 0. And then I need to plot negative 1 comma pi. 1 comma pi is to the right of the pole, and then guess what? Negative 1 comma pi is to the left of the pole. All right, so there's that point right there, and guess what? That Excuse me, that's not negative 1, that's 1 comma pi. So I'm sorry, scratch that. Okay, well, that's 1 comma pi. That's what I meant to say. So 1 comma pi is to the left of the pole, but then you got to reflect it. Okay, and guess what? It appears over here to the right. All right, and this is negative 1 comma pi. So I was trying to talk about reflections. So when the radius is negative, as you guys know, so this is r comma theta. When the radius is negative, you got to reflect it across a pole. All right, now we need to determine the y-intercepts. And now I notice that a is 3. Okay, so look at the normal function up here. Since a equals 3, we're talking about y-intercepts. And that, my friends, we found out in the lesson as well. So I got to go up 3, down 3. So up 3, down 3. Now, if you want to figure that out, if you don't understand that, what you do is you plot a point. I'm kind of running out of room, but I'll do one more. Okay, so here we go. Plot one more point. So we're going to substitute in pi halves because on the y-axis that's pi halves, right? So when theta is pi halves, watch this. You substitute in and you evaluate. So if you forget all these things that I'm talking about, you simply pick either 0, pi halves, or pi, or 3 halves pi, and you substitute it and see what you get. It's that simple. So really there's a lot to do when you don't remember everything, okay? And that's another thing I teach in all my lessons, like what do you do when you forget? Now cosine of pi halves is 0, times 4 is 0, plus 3 is 3. So 3 comma pi halves is on the graph, and guess what? That's up top here. Okay, you have a y-intercept. And now you draw your limacon. So I've done a lot just for one example. Notice that. There was a lot of analysis right there, which is what this mind map is all about. If you understand everything in this lesson that I'm giving you here, then you've really learned quite a bit. Okay, so let me switch colors here and let's graph your limacon with the inner loop. Okay, so here we go. That's not symmetrical. Need to do, let me try that again. Aha, that's a good one. Okay, so remember this point's not on the graph at net 1 comma pi. That was just an illustration. Okay, it goes through the pole and it goes through 1 comma 0. Okay, so that pole is a point on the graph. And then it also goes through 7 comma 0, which I illustrated earlier. And there we go. So the a values represent the y-intercepts. I showed you how to get the x-intercepts numerically by substitution. But again, there's an easy way to get them. You just add and subtract a and b. You can get the information that you need. And as long as you know that since you're dealing with a cosine function, it's symmetric about the polar axis, you're good to go. All right. Now let's switch and let's take a look at the next function here to the lower left here. All right. R is equal to 3 sine theta, 3 plus 3 sine theta. So first of all, let's write down the general form underneath it so you know what I'm talking about. So this is R is equal to A plus B sine theta. And notice A and B are both 3. A equals B, which equals 3. And when A and B are the same, you have a cardioid. Okay, cardioid is a special name for heart-shaped function. Heart-shaped, that's where the name comes from. Okay, so we should expect a polar function to look like a cardioid, not with the inner loop. Okay, A and B are equal. So watch this. A plus B is 3 plus 3 or 6. There's your maximum radius. All right, A minus B is 3 minus 3 or 0, and that's why there's no loop. Okay, just so you know. Now, if you can't remember to just add and subtract A and B, here's what you do. Okay, when theta equals 0, you substitute it in. R is equal to 3 plus 3 cosine of 0. Now we know that cosine of 0 is 1. 1 times 3 is 3. And 3 plus 3 is usually 6. So 6 comma 0 is on the graph. Okay, and so when I see A and B are both positive, okay, I know that we're going to, actually, hang on. I put cosine, not sine. What happened here? I wrote down the wrong function. Let me change that. Oop, scratch that. Okay, it's getting late. I wrote down the wrong function. Sine of 0. Okay. So, what do we have? So let me start over. Sine of 0 is 0 times 3 is 0. Plus 3 is 3. So 3 comma 0 is on the graph. Oh, you go up 3. Look at that. Okay, this is a sine function. Oh, you know what I did is my previous work was too close to my work that I'm working on, and I just misread it. So let me just do this here. I'm going to bring this down to separate it. Okay, there we go. Okay, so I'm dealing with a sine function, which is symmetric about the y-axis, not the polar axis, and we're going to go up 3. So starting at 3 comma 0, up here. Okay, we're at 3. Well, how about when it's maximum of pi halves? So I got to substitute in pi halves. Sine of theta is maximum of pi halves, so r is equal to 3 plus 3 sine of pi halves. All right, and I know that sine of pi halves is 1 times 3 is 3, plus 3 is 6. So 6 comma pi halves is on the graph. Well, where is that? Okay, so on this one here, oh, excuse me, so 3 halves. What am I doing here? 1. So yeah, I said that right. So, oh God, Ainsworth, man, I'm making so many damn mistakes. Oh, so 3 comma 0 is not up there on the y-axis. Okay, come on, it's 3 comma 0 is over here on the x-axis here at 3. I'm not going to redo this video, I'm just fixing it. Okay, because it's too late. I'm working too late. And as you guys know, I either make my videos too early or too late. And because I work too hard. So let me just redo this here. Okay, so what do we have? Let me just fix a few things here. Okay, so I've got my x-intercept at 3 comma 0. I need to plot 6 comma pi halves. Okay, that's up 6. So 2, 4, 6. There we go. That's 6 comma pi halves. Pi halves is up top here. Okay, and then if you want, you could put in negative 3 pi halves as well, or just 3 pi halves. Okay, but let's do some analysis here with the sine function. All right, sine that tells me that it's symmetric about the y-axis, symmetric about y-axis. There we go. And then I need a I know that a is 3 here. So a equals 3. Those are x-intercepts. So at 3 and negative 3, so I can plot the other one. I'm going to plot the other one. And then I got to figure out what type of limacon it is, which I should have done first as I'm looking back at it. So here we go. So a divided by b. Oh no, I did do that. A and b are the same. It's cardioid. All right, and so cardioids go through the pole. All right. How do you know? Well, you can go. You can put pi in there. You could put different angles in there. But yeah, it goes through the pole. All right. And so let's sketch. Okay. So here we go. Heart shaped. There we go. There's your cardioid heart shaped function. All right. This is not my best video, but I'm going to continue because I'm doing this for you guys, and being human, making mistakes is okay, I guess. It doesn't have to be perfect. Some people when they run videos is like they have to be perfect, so they'll spend like 10 hours doing this thing. And if I had that kind of time, I would, but I don't have that kind of time. So here we go. Let's do another one. Okay, so in this one here, so r is equal to a plus b cosine of theta. So a is 5, b is 3. I'm talking about their absolute values. And so let's take a look at the ratio of a to b. And this is 5/3, obviously. And again, I'm talking about the absolute value here. Okay, and guess what? 5/3 is equal to 1 and 2/3, which is greater than 1 but less than 2. Okay, so when that happens, when you're greater than 1 and less than 2, in fact, let me write it like that. So 1 and 2/3 is between 1 and 2. Okay, Now, when you have a limacon like that, you have a dimple, okay? You have a dimpled limacon. So how do you figure that out? So here we go again, a plus b. 5 plus 3 is 8, there's your maximum. B minus a is 5 minus 3. Oh, excuse me. Oh, no, no. A minus b. Not b minus a, but a minus b. Got that backwards in this case. So a minus b, and that's 2. But again, if you don't remember that stuff, here's what you do, okay? What you let theta equal 0, because this is cosine now. This is cosine stuff here. You use 0 and pi for cosine, but pi halves and 3 pi halves for sine. So when you want to figure out the radius, you just substitute 0 in, and you get 5 minus 3 times cosine of 0. And as I've always said, cosine of 0 is 1, times 3 is 3, 5 minus 3 is usually 2. So 2 comma 0 is on the graph. And guess what? A minus b is 2. So that's a point on the graph, so let's plot it. That's where your dimple is, right there. Okay? You know that from experience, guys. And if you go back through your lesson, okay, and your homework, okay, you'll see all of this. And that's why I always say do lesson first, make sure you understand it, then do your homework, and then do your mind maps, and then you'll get it, okay, if you put in the work. All right, let's see if you guys put in the work. So cosine here of pi, let's go pi. So let's figure this out again. So 5 minus 3 times cosine of pi. Cosine of pi is negative 1 times negative 3 is 3, and 3 plus 5 is usually 8. And there's your max. So 8 comma pi is on the graph. Well, where's 8 comma pi? Well, it's over 2, 4, 6. It's over here. Okay? So there's that. Now, here A is 5, and this is symmetric about the polar axis, so these are y-intercepts. So y-intercepts when you're symmetric to the polar axis. So you graph your y-intercepts, so you go up 5, down 5. And if you go up 5, down 5, you have some more points to plot. Okay, and then here we go. I'm going to do my best attempt at drawing a dimpled limacon. Okay, so dimpled meaning it's got to go through here like this. It's got to be concave. And it's got to go through this. It's got to hit 8. And it's got to come back through here. Okay, not the smoothest limacon at all. So if you, thank God we have one nut, right guys? Okay, so there we go. And so if you need to clean it up, you do it. Okay, so it's got to go through that point. There's the dimple. It's got to go back through here. So like I said, it takes a little bit of effort. It's not the easiest thing to draw, but do what I'm doing, okay? Oh, there you go. Look at that. After a few attempts, I got it. Okay, and there you go. That's not bad, actually. If you look at the Desmos and compare it to Desmos, that's pretty good. I'm pretty proud of myself. But as you can tell by watching me, first of all, it's not easy. And then second of all, it takes a few attempts. So you either do this in pencil or you have OneNote where it's all digital and you can just redo it. So you're seeing me doing a lot of mistakes tonight, but this is good because guess what? I'm human and this is what's going to happen to you. This is a realistic thing that happens. So I'm not rerunning this video here because it's taken a lot of time, okay? You guys, it takes me a lot of time to run all these things for you meatballs. So just hopefully you can appreciate it. Okay, so here we go. Last one. R is equal to A plus B cosine of theta. Okay, A is 3 and B is 1. I'm talking about their absolute values. And so what you want to do is take a look at your A to B ratio, which is 3 divided by 1 or 3. And this is greater than or equal to 2, which means you have a convex limacon. Convex, the opposite of concave, which means it's got a flat spot. And I've talked about that in my previous videos. Okay, it's the opposite of the dimple. Dimple is concave. So if it goes inward, it's concave, but we have a name for it. It's called a dimple. All right. The opposite of inward is outward. So if it has a flat spot, it's concave. convex. You just have to understand the vocabulary and what it means, which means you have to study geometry because that's a geometry term. Okay, so now what do we do? So theta equals 0. This is cosine, so I'm going to substitute in 0. So r is equal to 3 minus cosine of 0, which is 3 minus 1 or 2. Okay, there's your flat spot. Okay, at 2 comma 0. Now we substitute in pi. Okay, and so what do we get? R is equal to 3 minus cosine of pi. And as we know, this is negative 1. And we have 3 minus a negative 1. That's 4. So R is 4. So 4 comma pi is on the graph. So let's plot these. So 2 comma 0 is here. There's your flat spot of the limacon. All right, 4 comma pi is over here on the left. There's your maximum radius. This is max radius. And then these values, A is 3. A is 3. This is y-intercepts. Okay, and if you don't believe me, substitute in pi halves. So let's do it just for funsies here. So here's pi halves. I'm going to substitute it in. R is equal to 3 minus cosine of pi halves. And as you guys know, cosine of pi halves is 0, so you get 3. And 3 comma pi halves is on the graph, which is at the top. Okay, so here we go. This is pi halves up here, right? You know the unit circle. And the other one's down here at negative 3. So up 3, down 3. Okay, and then left, what was it? Left 4. Okay, so here we go. Let's draw the limacon. And it's convex and it's got a flat spot, so I'm going to just really make it a point. It's really not perfectly flat here, but you know it's. Let's see if I can draw this okay. Hey, that's pretty good. All right, that's not bad for me. Okay, it's not easy to do on a glass computer, by the way. Okay, and there you go, my friends. There is a full-on mind map illustrating all the concepts, I guess, of all of the 4 different types of limacons. And all you guys need to do is go through this, not once, but twice, 3 times, 4 times, whatever it takes to absorb it so it becomes a part of you. Because remember 2 things. Number 1, if you can't write it, you don't know it. If you can't teach another classmate using the Feynman technique, Richard Feynman from physics, one of the most famous teachers and physicists of all time, if you can't teach it to a classmate, then you don't know it. So you got to go through your mind maps until you can really teach another person so they understand it. And when that happens, you know what you're talking about. All right, so there's my little mind map for you guys for limacons. Hopefully I'll see you in the next video and hopefully in class. See you then. Bye-bye.